The inspiration for the CGI trailer was based upon Ray Harryhausen's films Jason the Argonauts and Clash of the Titans. The team wished to create a homage, taking the iconic stop animation of his films but transforming them into a 3D version. According to Harrod 2010, Ray experimented with 3D in the early 50s but soon realised that stop animation would result in a better quality of motion for the characters rather than 3D. The two iconic key elements of these two films were the skeleton fight scene and the Cyclops scene. When realistic rendering of the skeletons, Van der Stern 2010 suggests adjusting the haze and clouds effect so this would allow the models to stay consistent to the footage on the day of filming. O'Keefe 2012 explains that using bump maps will enhance the definitions needed. This was applied to the Cyclops after modelling in 3ds Max by taking it into Mudbox and producing bump maps which finalised the finished look. The ripstick was used for its unique design, allowing it to transition into a hoverboard. Christensen 2012 explains how rotoscoping creates a matte image of the object which allowed the wheels to be hidden by cloning out frame by frame. Particle systems were then added to create jets, as well as a dust effect. This sign was a subtle effect that was added. An image was created in Flash and then placed in position of the original sign. A clone of this was made with the opacity dropped and a smoke effect was placed on the clone which allowed for a dirtier look. To make the sign appear as part of the scene, the clone tool was used to replicate part of the bush, so that it would sit in front and provide depth to the shot. A blur effect was then applied and changed through the timeline to allow the object to pull out of focus with the footage. Cambridge in Colour explains that the depth of field shot allows for a smooth transition between areas that are in focus and areas that are blurred. This scene uses this feature to allow for the depth to be the focal point and draw the viewer's interest into the right places. The time tear is a distortion in time reality rather than natural disaster, so elements for non-realism were required. The main tear was created using Photoshop. Additional cracks in the earth were also created in Photoshop and are revealed gradually using masks. Douglas 2010 explains how low contrast footage can cause issues with rotoscoping, however because the scene was brightly lit these problems were easily avoided. This was used for the bush to replace it in front of the main tear. CC lens allowed for a time distortion effect. This was used in conjunction with colour change which from then on was replicated throughout the footage. The first element of the scene was the animation for the skeletons. It was important to show their sinister attributes through animation. Slick explains that the rig is the skeleton the mesh of the object. This rig is an essential setup to enable successful character animation. Using this animation, the footage was placed underneath and effects were applied to blend it all together. The chest was rotoscoped out, a colour tint was applied and then blurred to allow the outline of the chest to show the glow. The character was also rotoscoped out for this to prevent the glow appearing over the top of him. Camera track was also applied to the text to allow it to follow the lid of the chest. Perkins 2011 explains how camera tracking is essentially tracking the motion of the footage and applying the motion to the text. Brinkman 2008 explains that motion blur is essential to add into the realism of movement. With the addition of motion blur to the light sword, this enables a smooth movement rather than jumping across the frames. Autodesk defines their Mass Effect system as a physics calculator to be used in predefined animations. This allows for real-world factors to take place within the animation to produce realistic results. This can be done by changing elements of the object, for example bouncy and density. This was applied to the bones and skeleton to enable this defeated animation. With this scene, the camera angle needed to be accurate to replicate where the 3D models would appear in conjunction with the live footage. Coulson 2010 states the importance of measuring accurate camera coordinates in relation of the object being placed in the scene. These measurements were then being used in 3ds Max to correctly position the skeletons. The Cyclops appears from around the side of the building, and for added realism he needed to react with it. Once again Mass Effects was used. It enabled quick and easy animation through time and allowed for realistic factors to be incorporated. The Cyclops was blended into the footage with Refine and Trick Matte. Sky replacement was achieved using the inner and outer key, and a custom sky was created with Photoshop. Camera wiggler, film grain and colour adjustment were once again added into the final composition. Z-depth was attempted when rendering the Cyclops, however as the background footage wasn't out of focus it didn't prove effective with the scene and the team felt the Cyclops was an obvious factor, therefore Z-depth would be detrimental. Initially, After Effects was going to be used to create the rain using trapcode, however as the shot was angled upwards, the rain failed to look realistic in the scene and so 3ds matte particles were used instead. When rendering, motion blur was added to the camera so that the rain looked as if it was falling at speed. Foster 2010 states that the illumination of the green screen is highly important and in addition having the object in contrast to the screen so that the removal when using key light is an easier process. This allows the user to remove a colour from the scene, in this case green. Refine Matte is then used to blend the object into the scene.